Okay, so we're looking at trig ratios. In grade 10, it's all about right-angled triangles and looking at the ratio of sides in right-angled triangles. So some definitions have been invented, I guess you'd say, that relate the opposite side to an angle, the adjacent side to an angle, and the hypotenuse. In your calculator, you have a whole bunch of ratios of those sides saved, depending on what the angle is. In the old days, it would be a chart that you had to look up. Okay, so what's really important is that we know what is the opposite side, what is the adjacent, and what's the hypotenuse. Hopefully you remember that the hypotenuse is always the longest side. So in any right triangle, it's always opposite the 90 degree. Okay, the legs are always the sides that form the 90 degrees. Okay, and now we want to label what sides are opposite an angle and what are adjacent. So if we're referencing angle A, the side adjacent to it touches it. It actually forms it with the hypotenuse. If we are looking at angle A, the side opposite doesn't touch it at all. Okay? So if your point of reference changes to the other acute angle of the same triangle, the opposite and adjacent sides will change as well. So if I now go to this angle, then this side would be my adjacent and this would be my opposite. Okay, so it says label the hypotenuse and the sides that are opposite and adjacent to angle B. So this is your hypotenuse, always opposite the 90 degrees. This is adjacent, it's touching angle B, and this is not touching at all, so it's opposite. So, similar triangles. If you remember back to junior high, those are triangles whose angles are congruent or equal and whose sides are proportional. Okay, so it's basically an expansion or a shrink, right? A compression. But what happens is these angles, for example, here are exactly the same. So this side is proportional to this. If we multiply this by something, we will get this side. Okay, so take a look. This one's easier to figure out. If we if we multiply this by 2, we get 4. If we multiply this by 2, we get 2. If we multiply this by 2, we'll get this. Okay, as long as the angles are the same. And we've got two angles, 90 and 60. So this would be 30, 90 and 60. So this would be 30. They have to add up to 180. Okay, so trig ratios. Here they are. So the three sides of a right triangle can be compared to each other using trig ratios. These trig ratios have special names. The three primary trig ratios are sine of A. So this is the full word. This is the abbreviation. It looks like sin, but think, math is not a sin. So we don't abbreviate it to say it that way. Just say it as sine, right? It takes the same amount of time. Just in letters, it's the abbreviation. That's going to be opposite over hypotenuse. Cosine is cos. Okay, it's abbreviated. And so that is adjacent side over hypotenuse. So both of these are over the hypotenuse. Sine is opposite, cosine is adjacent, and then tangent abbreviates to tan, and it's opposite over adjacent. Okay, so this is opposite over hypotenuse, this is adjacent over hypotenuse, this is opposite over adjacent. Okay, so sometimes there's a little acronym that students use. SOHCAHTOA. SOH, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. And there's songs and ditties and all that kind of stuff. If you look up on YouTube, ways of remembering that. You will get this on your formula sheet, but it is a good idea to memorize it. So it says use the triangles on the left to find the ratios of the sides and compare the values of the trig ratios, round to the nearest hundredth. So I'm just going to do a dual screen here. Okay, so that you can look at these here. Okay, ratios of the sides and compare the values. So, so triangle on the left, this one here, if we're looking for the opposite side to 60, that's 1.73. The hypotenuse is 2. Okay. Then here, this is on the bigger one, it'll be 3.46 over 4. Get out your calculator. Okay, so 1.73 divided by 2 is 0.865, and then 3.46 divided by 4 is 0.865. Exactly the same. Okay, so 0.865. So that ratio is the value of sine of 60. It's opposite over hypotenuse, and it's the same. They're all the same. Okay, adjacent to 60 is 1 in the small triangle, hypotenuse is 2. Adjacent to 60 in the big is 2, hypotenuse is 4. So when you simplify that, you get 0.5, you get 0.5, so that means cos of 60 is 0.5. So in your calculator, I want you to check and make sure you're in degree mode. So in a graphing calculator, you press the mode key, go down and make sure that degree is selected. The default setting is radians. So make sure every time that after you reset your calculator, you're going to have to make sure it's in degree mode. If you have a scientific calculator, then you'll see a little D somewhere on your screen. If you see an R, then you need to change it to D. Look for a mode or DRG button. Okay. So now if we go cos of 60, what do we get? We get 0.5. That's what we thought it was. If we do sine of 60, what do we get? We get 0.866. A little bit off from what we had, but maybe our sides are rounded values. Pretty close. And then tan is opposite over adjacent. And those will all be equal to 1.73. And again, if you go tan of 60 on your calculator, you get 1.73. Okay. All right. So now I'm going to go back to full page. Go down here. It says state the 3 primary trig ratios for the indicated angle as a fraction and as a decimal. So we want sine of S, cos of S, and tan of S. Oops. S. Okay. And so label these sides before you even start. There's your angle that you're dealing with. This is always the hypotenuse. This is touching it, so this is the adjacent, and this is the opposite. Okay, so sine of S is opposite over hypotenuse. Okay, and so reduce that. That's going to be 4/5, and that's equal to 0.8. Cosine is adjacent over hypotenuse. That reduces to 3/5, so that's 0.6. And tan is opposite over adjacent. Reduce that, and that's 1.3 repeating. Okay, so actually rounding that, that would be 1.33 if you're rounding to the nearest hundredth. Okay. Next one, so sine of G, cos of G, tan of G. So here, opposite the 90 degree is our hypotenuse. This will be the opposite, and this will be the adjacent. Now we don't know what that is, so we're going to have to get the adjacent. I'm going to call it x. So Pythagorean theorem, x squared equals hypotenuse squared minus the other leg squared. So calculating that is 17 squared minus 8 squared is 225. So x is the root of 225, which is 50. So sine of G is opposite over hypotenuse. Cos is adjacent over hypotenuse, and tan is opposite over adjacent. Now, decimal-wise, what are these? Okay, so 8 divided by 17 is 0.47 to the nearest hundredth. 15 divided by 17 is 0.88. And 8 divided by 15 is 0.53. Okay? And then now we want to calculate missing sides using trig ratios. All right, so the primary trig ratios exist for almost all angles, and lucky for you, these values are stored in your calculator. Really, the only exceptions are not from a triangle, things that you're going to learn if you go on to Math 20 and 30. So, question 4 says, use your calculator to state the value of the following ratios rounded to 4 decimal places. So this is just plugging it in. Okay, so again, make sure your calculator's in degree mode. Then tan of 32, close the brackets, is 4 decimal places, 0.6249. And tan of 84 is 9.5144. Pause the video whenever you need to. Sine of 58.9, 0.9, 0.8563. And then cos of 18.6, 0.9478. Okay, so those are the values of the ratios. So if we can find the value of the ratio, we know that the sides have to be satisfy that, right? So now use trig ratios in your calculator to determine the lengths of the unknown sides. So think about it here. I know this angle. I want to know what x is. That is opposite. Okay, this is adjacent. This is hypotenuse. So if I think about sine of 57, that's going to be x over 5. I only have one unknown because this is a value. It's in my calculator. So if I want to solve for x, then I'm going to multiply both sides by 5. So those 5s divide out, and I end up with getting x equals 5 sine of 57 degrees. So on your calculator, you go 5 sine of 57. And round to 2 decimal places would be 4.19. And whatever units, centimeters. You know that the opposite has to be less than 5 because it's a leg of the triangle. Now for y, that's adjacent. So cos of 57 is the adjacent over the hypotenuse. So that means y will be 5 cos of 57. Go to your calculator, 5 cos of 57. And that's going to be 2.72. Okay. This one's here, just x here. So I know 38 degrees. That's going to be opposite. This is adjacent. Okay. And so as long as we know an angle and one side of a 90-degree triangle, so 90 degrees plus another angle and a side, we can find the second side, whatever it is. So in this case, I would use tan. Tan of 38 equals opposite over adjacent. So x equals 12 tan of 38. Okay, so 12 tan of 38 is 9.38. And that is centimeters. Okay, now this is, yeah, that's proportional, right? That side should be smaller than the 12 based on my diagram. So some of our diagrams are a little bit off, but that makes sense. Okay, next one here, 42. We want to find both x and y. So this is your hypotenuse, this is your adjacent, and this is your opposite. So I'm going to start with tan of 42. That's going to give me x over 9. So x equals 9 tan of 42. Okay, so 9 tan of 42 is 8.1. No units, so I'll just leave it. Okay, now hypotenuse here. Now you could use Pythagorean theorem now if you wanted to, because I have two sides, right? So I could, but I want to practice trig. So now, and I always like to use measurements that have been given to me rather than rounded. So now for this, I'm going to use cosine of 42 equals 9 divided by y, because I want to show you what happens here. If you're looking for a value in the denominator, so think about, you've got to multiply both sides by y to get it out of the denominator. Okay, so then we would have, I'll just move this here, we would have y cos of 42 equals 9. Now, to get y by itself, I have to divide by cos of 42, both sides. So y equals 9 divided by cos of 42. So the thing to remember, if your unknown is the hypotenuse and you're using sine and cos, you're going to have to divide. So if your unknown's in the denominator. So now it's either multiplying or dividing, but this is when you divide, when your unknown's in the denominator. So 9 divided by cos of 42 is 12.1. Okay, and again, no units because it wasn't given. All right, so 12.1 should be, that's the hypotenuse, so it better be longer than either of the sides, which it is. So this one here, got 50, we've got this is opposite, this is adjacent, and this is hypotenuse. So gonna have to use opposite. I can use adjacent for tan. So tan of 50 is 30 over x. Again, our unknown is in the denominator, so we're going to have to divide 30 by tan. Okay, so 30, was it 30 or 3? Sorry. Yeah, 30. 30 divided by tan of 50 degrees, so close that, is 25.2 centimeters. Okay, and then again, I try not to use that. You could use Pythagorean theorem right now. Now I'm going to use opposite over hypotenuse, so that's sine of 50 degrees equals 30 over y. So y equals 30 divided by sine of 50. So 30 divided by sine of 50 is 39.2 centimeters. And that should be the longest side, which it is. Okay, so there are some questions listed there from your workbook to do. I've also listed them on your timeline. So that's trig. We're also going to do more of this in the next lesson, but this will get you started.